the final piece to the blockchain puzzle right now is storage. Because then you can actually create a functional Web3.
We're here today in Hidde Hoogland, which is a city in the Netherlands about 50 minutes north of Amsterdam by train. The reason we're here is to actually learn about how a Filecoin data center operates. We're on site at the headquarters of DCENT, which is the largest Filecoin storage provider in Europe and one of the largest Filecoin storage providers in the whole world. So we'll be learning about how a Filecoin storage provider actually operates, what type of hardware is required, what the business model looks like, and we're also going to be learning about how your data can get safely and verifiably stored on the Filecoin network. And most importantly, we're going to learn about how thousands of data centers around the world, just like this, combine to make up the world's largest decentralized data storage network, which is Filecoin.
Hey, welcome guys.
Hey, Hidde, how are you doing?
Fine, how are you doing?
Doing all right, doing all right.
Welcome. So, this is a whole new space compared to where we were a few years ago with Ethereum. We actually redone the whole building, so all the walls you see, all the floor tiles, all the roof, everything is completely revamped. We've thrown out everything we can find back to the concrete and the roof, and then we redone everything. Wow. So the cables you just saw on the picture, they are from the power station in the back, and they are all rerouted through the raised floor. So you can see these 160 amp 3-phase cables running through all the racks. Each rack row has their own cable, and you can actually see them moving into a power bar structure, where you can just click on 32 amp rack rails, which is extremely fancy. Yeah. You can there see that that's the network infrastructure entering the room. We have 2 dark fiber cables coming from various places in Amsterdam, and they all enter the room right there, and we connect them to our internal networking in these 2 boxes. That also includes the security cameras and the Wi-Fi and the door systems. There's everything is in here, which is pretty useful. And this is all, this is actually mirrored. So we have 8 10 gig connections going into our switch, but they are all being merged into one dark fiber going below the floor. And when they arrive in Amsterdam, they get split up again into colors. You can see the waves on the cable schemes. Okay. It's called DMUX.
So we're in the battery room here. Tell us what we have in the battery room. What is this all about?
Yeah, this was an experiment thought of between the team of Filecoin Green and DCENT. This was constructed about a year ago. We were talking about ways of making a storage provider run more efficiently and more cost-effective with implementation of things that are renewable. So the first project we worked together on was a solar panel array, which cut our cost by like 10% on power annually, which is super helpful to be a competitive SP. And the second project we thought about was a battery room. And battery rooms are pretty difficult because the basic law is don't invest in something that doesn't make an ROI. And batteries are just an example of you pay for them, they work for 10 years, and after 10 years, you make your money back. So it's a 0 ROI in 10 years. It's a bad investment, but it was still a pretty good thing to try, especially when during COVID, the energy prices went up. There was a time where these were really, really effective money-wise. So what you can see here is 4 stacks from Growatt. These are actually home/medium-sized business batteries. You can stack them onto 26 kilowatt-hour systems, or like 110 kilowatts in here. They're all connected to these hybrid inverters. And these inverters are then connected to about 50 solar panels each. And what they do is every morning when the sun rises, they are filling the battery systems between 6 and 9. Then they are filled, and then these battery systems will just hold on to their power. These systems will send that power to the data center until the sun sets. And when the sun sets, the power prices, they slowly go up. And we don't pay static price, we pay hourly rates, because on average it's cheaper. But these hourly rates during 8 and 10 in the evening are most expensive. So we put the battery systems to discharge during these expensive hours. So a few hours a day the data center runs on battery power, a few hours a day the data center runs on solar arrays, and during the night, of course, we use the main grid. So the first box is completely filled with basic Filecoin stacks. So PC1, 4 times PC2, and then a petabyte of storage and a backup battery, and just we copy and pasted that at 10 times. Well, the first 10 racks are identical with about 20 petabytes of capacity for clients. The second row is all filled with compute for helping customers and deal data. So actual clients sending us deals, we need to pack them and store them, and that's all done in the second row. The third row is still empty. It's reserved for an expansion. And the fourth row is filled with compute. There are like 200 graphics cards filled in these racks for Filecoin or AI or other protocols to work on. So each of these systems have about 10 GPUs. And they're all a combination of 3090, 4090, or A4000. So you can actually see the PC1, PC2, storage, and battery system. Wow. And they are all copy-pasted. So all of these have the same. Wow. I'm pretty sure that the Solana set is stored on these three above.
All right.
Yeah. Because these are one of the only systems that have a direct access to the outside world with 25 gigabytes, because they need to download so much and so often. The rest is all, yeah. So these have special access.
So the Solana blockchain is all stored. Pretty cool.
So tell us more about what you guys do in the maintenance room here. What do you guys use this for on a day-to-day?
So what we use the maintenance room for mostly is demoing and storing all of our components. We are running the data center next door. So if any components break, if anything is out of order, or if a customer requires an expansion or new components, we have everything in stock right here. We also have a few standing desks here to actually construct new servers. These are, for example, new 8-slot GPU servers from Gigabyte. These are AMD 3rd gen. We can fill them up with whatever components we need, but they can house up to 8 GPUs in a 2U system, which is something we haven't seen yet. Normally they're way bigger. And we have a lot of network components lying around here. All of the cables we might need, all of the fiber modules we might need, we have them in here. The same goes for all the server chassis. The most important thing here is we don't use this room that much for repair, because the servers typically don't break down. RAM don't break down, NVMe don't break down. And typically, if you run GPUs on a low enough temperature and a controllable wattage, they typically don't fall off the bus or break down as well. So the only component that actually dies sometimes due to mechanical failures are hard drives, because they actually have a spinning disk inside.
Can you walk us through what are the component parts of the Filecoin stack? What are the main pieces of hardware that you would need to do this?
Yeah, so the Filecoin stack is pretty intensive. So you need a lot of hardware knowledge and software knowledge to build the stack, but the main component of the stack are hard drives. You need a huge amount of hard drives to be able to store the sectors that will eventually earn you an income in the Filecoin ecosystem. These are the components where the data on the Filecoin is actually stored. But with only hard drives, you won't be able to set up a storage provider. You also need a lot of compute. So we have, for example, a really decent card, is the A4000. We use this card for a lot of stuff, but mainly mining blocks, doing proofs, and doing PC1 and PC2 or PC2 and C2 for the process.
The process, yeah.
The mining process requires PC1, PC2, C1, and these GPU components are used pretty frequently. And of course, also AMD CPUs. For the PC1 process, you need a huge amount of compute cores, and these are done quickest on AMD CPUs. So these processors and these graphics cards are important, but the most important, again, are the hard drives.
How do you kind of see this business that you have growing here? What's going to be you have like a 5-10 year plan that you're aiming toward?
The final piece to the blockchain puzzle right now is storage. That's a thing where most of the large L1s who already succeeded in what they're doing are now focused on. How do we also onboarding customer storage? Because then you can actually create a functional Web3. We have a huge amount of compute and hardware in Filecoin, which won't go away, which is already here for years, which has proven itself to being pretty resilient to market changes. They can tap into the massive amount of hardware that we have on Filecoin.
Solana had originally included in their original vision of the Solana blockchain and ecosystem was to have like a decentralized storage layer embedded, like underneath the actual blockchain, and then they realized like, well, Filecoin's basically already done this.
We really believe that sooner or later, the pieces will fall into place, and large-scale entities will be able to offload a lot of data into Filecoin, and then we are already at the position of utilizing all of those entities. Almost 70% of our hardware is focused on Filecoin, but the remaining GPUs and storage and bandwidth is now utilized into other deep-in projects, like for example I/O, or like for example we are working on protocols with Solana as well.
Well, this has been super interesting, Hidde. I really appreciate you showing us around. Really appreciate the tour. We've learned a ton of stuff today. Really appreciate you taking the time to show us all this.
Enjoyed having you here.